Good afternoon, everyone. My name is Oscar Diez. I'm working currently in the European Commission in the unit that is taking care of high-performance computing and quantum technologies. And I will talk today a little bit about both worlds, the HPC and the quantum technologies, and the activities that we are doing together with the Euro HPC. So let me introduce with a small explanation of what we are doing at high level at the European Commission on quantum. So I will start with the left side of the image. That is basically, probably most of you have heard about it. That is the Quantum Flagship. It's a research-based program. It's based. We are using Horizon Europe for the funding, and this is a 10-year program with more than 1 billion euros investment. This we started in 2018. And currently we are running the second phase of this program, of the flagship, the Quantum Flagship. The idea here in this second phase is move from what we call from lab to markets. So increase the TRL, technology readiness level of these projects, and we are focusing more now in the commercialization of these technologies. Together with that, we have been funding different programs for what we call advanced digital skills, where we are, for example, creating a master's at European level. Sorry, one thing for the time, if you can enable it, because I don't know, it's still 20. Sorry, thank you. So as I was saying, the digital skills, so we have a master's program that we have created for different universities in Europe in quantum technologies. We have also created, as part of this flagship, the Quantum Flagship, we have created what we call the research strategic research agenda. This is a document that was created at the beginning of the flagship. It was created by the quantum community in Europe, and the idea here is to get all the objectives that we have set in 3 and 6 years for the Quantum Flagship on research. This document came together with a set of key performance indicators that we are reviewing every year, and both of them are public. So one of the things that we have done recently, in fact, last month, we launched the Strategic Research and Industry Agenda. So this is an update of this document. I invite you, this is open, this is online. You can go search for it in our website or in the internet, you will get it. And it's basically providing information of what are the objectives for all the different pillars. We are talking here quantum computing, quantum simulation, quantum sensing, quantum metrology, and quantum communications. For each one of them, we are providing what are the different objectives at 3 and 6 years. And there is a specific chapter now, that is focused on the integration of quantum computer and supercomputers and HPC. And one of the things that we have included, as you can see, in the software research and industry agenda, one of the things that we have done include the word industry, and this is done on purpose. One of the things that we are now doing is focusing more on commercialization of these technologies, and we have launched also another 2 programs that are helping us on this, that is the deployment of infrastructure. One of them, I think, has been, you probably know about it, it has been discussed this morning, it's the EuroQCI. It's a QKD network at European level with 26 member states, and we have 2 segments, one for one terrestrial and one on space. And the other project, that is the one that I will talk today, is EuroQCS. That is basically focusing on building and deploying a network of quantum computers with the supercomputers. Another project that we have, and we are heavily working now on that, is the European Chips Act that have been announced a few months ago, so last year, and there is a very big part on quantum that we are now focusing on creating pilot lines and production lines on quantum chips. So let me go a little bit more into the left part, into the research, so you get a little bit of a picture of what we are doing there. Since 2018, we have been working on that part. We have been focusing at the beginning, when we started, because there were the technologies that were more more prominent, what has been in superconducting qubits, neutral atom, trap ions. We have multiple projects. These are some of the projects that we have currently now. Some of these projects, from these projects, companies were born, like, for example, Pascal with Pasquans, the first version of the Pasquan project, or AQT with trap ions with the previous projects that it was Action. And currently, as I said, we have different projects. We have extended the number of technologies, so the idea is to focus not only in a few, but try to get as many as possible, because we don't know what are the ones that are going to be selected. And recently, this year, we have launching projects in photonics. So 2 years ago, we launched also projects in spin qubits, in semiconducting qubits, and MV centers. Also this year, we are launching another project. So until here, I gave a little bit of overview of what we are doing in research in quantum. So now I will move to the other part of the unit, that is supercomputers. So a few years ago, we decided to prepare a new regulation for supercomputing in Europe. One of the things that we did is, as part of the regulation, is create a new joint undertaking, is the Euro HPC joint undertaking. And here, one of the things that, apart from other projects, one of the main projects that we have that we did, it was the procurement of supercomputers. We started to do it in a gradual scale. So we started with what we call the petascale supercomputers, normally below 50 petaflops. And we have currently, I think we have at least 5 supercomputers, like, for example, the one in Meluxina in Luxembourg. And we launched also, we have procured 3 what we call pre-exascale supercomputers that are between 100 and 500 petaflops. And we are also launching, so we are going to procure also what we call exascale supercomputers that are more than 1 exaflop. And this is going to be installed in France and Germany. Just to let you know that some of these supercomputers are currently between the top 10 at world level, and the ones that we are going to get, of course, they will be higher. So now, sorry. One of the questions is why hosting supercomputers, why quantum computing in supercomputing centers? And this is one of the things that we have seen since the beginning, is that these supercomputer centers, they have been operating these supercomputers for a long period. So we're talking more than 50 years. So they have a lot of history on maintaining this supercomputer. So you have things related to cooling, to security, to access to the supercomputer that they have been doing since a long time. An example is the open calls that we have, where researchers that are working in a specific, for example, in material science, they will have access to this, with a specific project, they will have access to these supercomputers. So they can say, I have a project, I want to have so many core hours for, I don't know, working in material science, and they will go and we will give them access to this supercomputer in one of the supercomputers that we have. Another one is the fact, and is linked to the previous one, is the fact that these supercomputer centers are a hub for scientific research and collaboration. So we have a lot of researchers that are using already these supercomputer centers, that they don't mind if what is behind is a TPU, a GPU, a CPU, whatever. They want something that is running as fast as possible and that is doing it better than it was doing it before. And a good example of that is the Center of Excellence. So we have currently at European level more than 15 Center of Excellence all over Europe that they are focusing on specific domains. So for example, we have in material science, we have in weather forecast, we have a specific in artificial intelligence, and these people are providing support to the rest of Europe on this type of codes. So they have a specific codes that has been developed, and they provide access to the researchers and support to the researchers. So why don't we use that one? Another thing, that we know is that we have seen, especially in the NICS area, that these quantum computers need classical computers. So we see that some of the we have some strengths of using hybrid algorithms, and this is something that we can do and has been done with different type of different accelerators in the supercomputer centers, and they have this They have this know-how, and the same for educational. So we have these researchers that currently use that, these supercomputers. Why we are not going to tell them how to use quantum computers and how to adapt their codes in order to run these quantum computers. An example of this is, for example, the courses that supercomputer centers like LUMI have provided in quantum computer recently. Another, and this is most reason, or another two reasons of why we need to host, well, we should host quantum computers in supercomputer centers, is the fact that we know that for a specific cause, for a specific in specific cases, quantum computer can be faster than classical computer, and we know that in some cases, in some applications, they are having big problems in supercomputer centers or scaling that application, those applications. So it's not a question of putting more nodes that it will solve the problem. An example of this, it could be what is done at molecular quantum chemistry, for example. And another one is the use of energy of the supercomputer centers. So some of the supercomputer centers, especially when we go to exascale, we are talking more than, in some cases, even 40 megawatts. That is a huge amount of energy. Now, with all the problems that we have with climate change and everything, the people will start to put more questions on what is going on there, and until when we will start to permit that we can use this type of energy for this. And quantum computers, it could be a solution for that. So one of the things that we have identified is different integration layers on HPC and quantum. On the top, we have applications or users. For us, this is probably the most important one. Here, what we need to do for the integration is focus on selection of specific use cases that are good for HPC and for quantum. Also, access policies, how these researchers will be accessing the computers. If we need to change the current access policies to the supercomputer centers, the support that we will need to provide to those researchers, skills that we will need to also to provide to the researchers. And for that, what we are doing is something similar to what we have before. So we are not reinventing the wheel. It's Quantum Center of Excellence, and I will provide one slide, some information about that one. On the middleware, the integration, especially the libraries for the integration between the HPC and quantum, the scheduler and the resource manager that the researchers are using for launching their jobs, this will need to be adapted to be integrated with quantum, and also things like, for example, virtualization and multiple user support. On the software, we have quantum software stack and everything that is related to the integration of the debugging, the data transfer between the HPC and the quantum computer, how it's going to be done, and also everything that is related to benchmarking. And on the hardware side, we have everything that is related to the interconnect. At hardware level, the protocols that will be used, if we are going to use or not emulators and how it's going to be integrated. Also the interface to when we are having multiple quantum computers in the same supercomputer center, how we are going to integrate it. And also everything that is done related to the hardware monitoring and telemetry. That is something that supercomputer centers have been doing for ages. So if you want more detail on this one, my understanding is Laura, she's going to talk about maybe some of these things, because she has been also, she's one of the main responsibles for creating the chapter on the integration between HPC and quantum in the SRAI. So if you have more information, you can find it in the document. Here I put an example of what it will be, and this is of the software stack that will be between the integration. I will not go to the detail. The idea is that for the user is similar to what we have now. So it's not going to change. So before it was using a scheduler in order to launch the job. There was a workflow inside, but internally a lot of things needs to change. A lot of things needs to happen. So why? This is one of the question that we get, why we are buying this, why we are doing this. So we hear that this is still very early stages, that the quantum computers are not ready, that they are very expensive, that there is not people that knows basically how they work, especially in the supercomputer center, that there are not too many use cases at this stage, and also that you will add more complexity. So I think the fact that we have all these issues and that we need to sort it out, the sooner we take it, the better. This is one of the reasons. So they will help the companies to understand, especially the quantum computer companies, to understand what is the reality when they are going and they need to do 24/7, when they need to have an SLAs that they need to meet, all these type of things. This is one thing. The second is very good research for the quantum computer companies, but it's not, especially at the beginning, it's not enough. So they need, for them, and for some companies, it's better to procure equipment that you start to use it and then they can say somebody else is using this equipment, is being currently used by researchers, and this is how it's working, and this is going to help them also to sell more. So Euro HPC QCS, so what we are doing here is try to get, sorry, somebody is calling me. So try to get more or less the same format that we have for the procurement of the supercomputers, also for the quantum computer. So the idea is that we did it in stages. So here we are doing it the same. The first one is HPC QS. It's a project that is when we have procured 2 Pascal quantum simulators of more than 100 qubits, and they are installing, they're going to be installed in France and Germany. One of the things, this is a kind of very early stage project. The idea here is to start to find out specific use cases for this type of applications, also work on the resource manager and the scheduler that it will be used, and also coming with generic programming languages that could be used. The second one, that is probably the most important one, is the Euro HPC QS. Euro QCS. This is we have the first stage. It was we did a selection of 6 hosting sites all over Europe. So we did a call. Different supercomputer centers apply for the call. We selected 6, and this idea is to have as many as diverse quantum computers as possible. So in this first stage, we'll have 6 quantum computers with 4 different technologies. So we are talking about superconducting, photonics, trap ions, and neutral atoms. And we are now launched, in fact, it's now, I think it's open, the second call for selecting more hosting entities for different technologies is possible. So this, here you have a little bit more information about the different quantum computers that we will buy and the different technologies. And before finishing, I want to give also an overview of the Quantum Excellence Centers call that currently is open. You have the link there. If you search online, you will find. This is basically what we are doing, something similar that we have done for the Supercomputer Center, where we will have excellence centers that they will focus in applications, especially at this first stage applications on HPC and quantum, and they will develop these applications. We will launch 2 Quantum Excellence Centers, one for science and one for industry. Here you have a little bit more detail. I don't want to go too much into detail here. Just to let you know that we are going to launch calls also with the Euro HPC for integration of the hardware and the software. The second selection of the hosting entities, as we said, we are going to launch a call also for benchmarking, working on having benchmarkings, and middleware, another call for middleware between HPC and quantum computing, computer and simulation integration, and also one for universal access. And just to finish, I want to say that this is not only being done here. There are a lot of projects at European level, like, for example, in Spain with Quantum Spain, Quantum Inspire. We have also in Finland. We have in France also here. We have projects. In Germany, we have projects. In Italy, we have projects on this integration, and we are also collaborating with them. And also, as you probably know, at Japan, especially in RIKEN with Fugaku, they are pushing a lot for this integration, and also in the States, especially in the Oak Ridge National Laboratory. And we are currently preparing collaborations with both Japan and US. And with this, I finish my presentation. If you need more information, you can go to qt.eu website, and I will be here if you have any questions. Thank you very much.
Is there any question?
Hello, thank you very much. Could we get slide 9 up, please, again? Is that possible?
Sorry?
Slide 9.
Okay.
Yeah.
One moment. Let me see which one is 9.
This one.
This one.
This is amazing picture that you have on the top. I made that.
Okay, apologies.
Would you be so kind to just put the reference of the paper
Yes,
with
sorry,
the slide?
apologies because I got it from one of our projects. I think there was an sorry, so I will.
It's
I
an
will
amazing paper. It's the best paper I've ever written in my entire life. So if everyone reads it, I would be very pleased.
So apologies. Yes,
Yeah.
I thought that.
No,
okay.
I will take a picture because I like it very much. Thank you.